Good evening, ladies and gentlemen. This is Pandra. I'm a graduate student at Bradley University, currently pursuing computer science. I'm representing my course CS690 Advanced Topics in Software Engineering and submitting my work of quantum computing to Dr. Vladimir Yusko. Here's my topic of contents, the agenda today. I'm going to be talking brief history, mechanism of the computing, and some real world examples with advantages and disadvantages of it. Quantum computers could spur the development of new breakthroughs in science, medication to save lives, machine learning methods to diagnose illness sooner, materials to make more efficient, devices and structures, financial strategies to live well in retirement, and algorithms to quickly direct resources such as ambulances. What exactly is quantum computing, and what does it take to achieve these quantum breakthroughs? Quantum computing is an area of computing focused on developing computer technology based on principles of quantum theory, which explains the behavior of energy and material on an atomic and subatomic levels. We experience the benefits of classical computing every day. However, there are challenges that today's system will never be able to solve. For problems above a certain size and complexity, we don't have enough computational power on Earth to tackle them. To stand a chance at solving some of these problems, we need a new kind of computing. Quantum computers leverage the quantum mechanical phenomena of superposition and entanglement to create states that scale exponentially with numbers of qubits or quantum bits. Let's go into the history of the quantum computing. The prehistory of the quantum computing begins early in 20th century when physicists began to sense that they have lost grip on reality. As early as 1959, an American Nobelist, Richard Feynman, noted that as electronic components began to reach microscopic scales, effects predicted by quantum mechanics occur, which he suggested might be exploited in the design of more powerful computers. David of Oxford published a theory paper describing the universal quantum computer, proving that if two-state system could be made to evolve by means of a set of a simple operation, any such evolution could be produced and made to simulate any physical system. These operations come to be called as quantum gates, and they function similarly to binary logic gates in classic computers. And Peter, who worked in AD&T, proposed a method using entanglement of qubits and superposition to find the prime factor of an integer, a rather valuable process, as many encryption systems exploited the difficulty in finding the factors of large numbers. In this principle, his algorithm would far surpass the efficiency of any known computer when executed on a quantum computer. In 1993, the theorem described how two particles which came into contact became entangled and part of the same quantum system. The quantum computer gains enormous processing power through the ability of bits to be in multiple states and to perform tasks using combinations of ones and zeros on both a 1 and a 0 simultaneously. All computational systems rely on a fundamental ability to store and manipulate information. Current computers manipulate individual bits which store information as binary 0 and 1 state. Quantum computers leverage quantum mechanical phenomena to manipulate information. To do this, they rely on quantum bits or qubits. Qubits have some quirky quantum properties that mean a connected group of them can provide way more processing power than the same number of binary bits. One of these properties is known as superposition and another is called entanglement. Qubits can represent numerous possible combinations of ones and zeros at the same time. This ability to simultaneously be in multiple states is called superposition. To put qubits into superposition, researchers manipulate them using precision lasers or microwave beams. Researchers can generate pairs of qubits that are entangled, which means the two members of a pair exist in a single quantum state. Changing the state of one of the qubit will instantaneously change the state of another one in a predictable way. This happens even if they are separated by a very long distance. Finally, quantum states can undergo interferences due to phenomena known as phase. Quantum interference can be understood similarly to wave interference. When two waves are in phase, their amplitude adds, and when they are out of phase, their amplitudes cancel. Here are some of the real-world examples. Microsoft Quantum Computing conducts a theoretical and experimental approach to creating a quantum computers and employ researchers, theorists, and experimentalists from mathematics, physics, and computer science in partnership with academic and research institutions across the globe. This mission is to advance our understanding of both quantum computing and its applications and implementations. IBM Quantum Computing offers students, researchers, and general science enthusiasts hands-on access to IBM's experimental cloud-enabled quantum computing platform and allows users to run algorithms and experiments, work with quantum bits or qubits, and explore tutorials and simultaneous around what might be possible with quantum computing. Quantum Artificial Intelligence Lab at Google Research is a joint initiative of NASA University Space Research Associate and Google, specifically Google Research, whose goal is to pioneer research on how quantum computing might help with machine learning and other difficult computer science problems. The lab is hosted in NASA's Ames Research Center. The Quantum Information Processing QIP group is based on HP Laboratories, Bristol, which is located in UK, and is part of Information and Quantum Systems Laboratory. Areas of interest of that includes quantum computation, quantum cryptography, quantum teleportation, and quantum communication. The D-Wave is one of the famous quantum computing industries. They're the leading now. D-Wave System is the world's first quantum computing company. Their mission is to integrate new discoveries in physics, engineering, manufacturing, and computer science into breakthroughs approaches to computation that help solve some of the world's most complex challenges. Some of the advantages are the main advantage of the quantum computing is that it can execute any task very fast when compared to the classical computer. Generally, the atoms changes very fast in case of traditional computing, whereas in quantum computing it changes even more faster. The principal advantage of the quantum computing is the prospect of quantum supremacy, where quantum computers would be able to solve important NP-complete real-world computing problems in polynomial times. The advantage of quantum computing is that it offers a new paradigm for how problems might be solved, which is very constrained circumstances permit revolutionary new solutions, which can in theory easily solve intractable problems. Some of the disadvantages of the quantum computing is even with the slightest disturbance in the quantum system can cause quantum computation to collapse, a process known as decoherence. So in another one is the qubits are not digital bits of data and cannot be conventionally conventional error correction. Error correction is critical in quantum computing. Even a single error in calculation can cause validity of an entire computation to collapse. The main disadvantage of computing is the technology required to implement the quantum computer is fully not available at present. The reason for this is the consistent electron is damaged as soon as it is affected by its environment, and the electron is very much essential for the functioning of quantum computers. Uh, according to theoretical research with quantum computing, every computer on this planet will become vulnerable. Even nuclear codes can be hacked with quantum computing. What will happen if it gets into wrong hands? Here are some of the internet-based references of my research, and some of my recommendations would be uh, it is really necessary for us for the faster processing of computations. There's still many challenges in quantum computers and even more opportunities to explore. Scientists and engineers are working hard to make quantum computing a reality. The real world implications of these benefits could be huge. One of the biggest and most talked about application of quantum computing is the medical sector, where the simultaneous power of technology has the potential to transform our understanding of human body and help in the development of new drugs. There is some serious high level physics going on when it comes to quantum computing. There's some who predict that quantum computing could help solve one of the most pressing issues facing in the world today. For example, modeling molecular interactions could also help scientists develop new agricultural products that improves fertilizers and cut greenhouse emissions, thereby helping tackle world hunger while minimizing environmental impact on food production. When you enter the world of atomic and subatomic particles, things began to behave in unexpected ways. Uh, in fact, these particles can exist in more than one state at a time. It's the ability that quantum computers can take advantage of. We're venturing into an entirely new realm of physics, and there will be a solution uses we have never even thought of yet. But when you consider how much classical computers revolutionized our world with relatively simple use of bits and two operations of zeros and ones, you can imagine the extraordinary possibilities when we have a processing power of qubits that can perform millions of calculations at the same moment. And my personal recommendation would be this: quantum computing is essential in various ways in for our future. It can help us for good and the bad, and it can be of a huge impact if all the individuals in educational institutions and companies would pitch in their pitch in their ideas together and make this like computation more better for our users. uh, I'm signing off. Here's my presentation for today, and thank you. Hope you have a great night. Thank you.